This is a Blender Python tutorial where we'll be going over a Python script that generates this seamless animation loop. Hey, I'm Victor Stepanoff. I'll be guiding you through this Blender Python tutorial. Today we're going to be working with metaballs and animated paths to create the animation that you see on your screen. I hope that you'll enjoy this tutorial and learn something new. To quickly start iterating on our script, we're going to be using some helper code to start iterating on our script right away. To get that helper code, I provided a link in the description under Start Code. Open that link in any browser, hit Raw, select the code and copy it. Now let's go back into Blender. Let's open the scripting workspace, hit New, and then paste in the code. Let's run this code and see what happens. So the main thing that happens is the scene gets cleared. We'll add a light, empty, and a camera right here. We also make the camera track this empty so we can move it around, but we won't be moving it around in this particular video. But this is our basic setup, and this will happen each time we run the script, so we can move stuff around, right? And it will regenerate after we run the script, as you can see. We'll be taking a closer look at some of the helper code at the end of this video, and also how you can get this helper code for yourself without having to copy around code. So make sure to stick around until the end. The very first thing that we need to do is add a metaball into the scene. And to do that, let's do it by hand and then copy the code that gets added into the info panel. So I'm going to hover over the 3D viewport, hit Shift A, select Metaball, and then ball. All right, so we have a metaball right in the middle of our scene. If we look at the bottom of the screen, you can see the info panel, and there is actually a call right here that will add the metaball for us through Python. So let's copy that. Actually, I'm just going to run the script so everything's cleared, right? And then I'm going to go into the create centerpiece function and paste in that code. We will remove everything from these parameters that we're passing in. So we're just going to have the metaball add function call. Okay, let's run our script. And you can see that we have a metaball getting added into the scene each time we run our script. I'm going to hit Z and select rendered to see the scene rendered. I'm using Cycles, the Cycles rendering engine in this particular scene. And we can see how each time I run the script, the light changes color. So the special helper function that we're using to generate the light will have a random color assigned to it. So it's not the metaball that's changing color, so there is no material assigned to it yet, but you can start seeing that, hey, we already have some kind of color going on in our scene. We can actually take a look at this helper function right above. It's right here, so we're adding a area lights, setting the energy, getting a random color. We'll take a look at that at the end of the video, and making the shape, setting the shape to a disk. All right, and also before we continue any further, let's save our project. So making sure that we can recover it if anything happens. All right, I'm gonna just open my tutorials folder and just save the project. And I'll also save the text. And also I'm going to just call it script py and save it there. You can save it, of course, anywhere you like and name it as you want. One thing that I want to set on this metaball right away is the render resolution. We select the metaball and look into the properties of the metaball. You can see that there's a resolution in the viewport and the render resolution right here. So this matters when we're, for example, I'm going to give you an example of the render. I'm just going to start rendering this particular image, right? There's nothing really to see here. I'm just going to stop the render as it'll be enough to show the point that I want to make. I'm going to put this in slot 1, then put another rendered image in slot 2. I'm going to set this to 0.05. All right, set that, and let's render that again. Just going to wait a bit. I'm going to cancel that render. And let's compare the two different render resolutions of the Metaball. So this is slot 2. This is the resolution that I'm sending right here. Right, this is 0.05, and then the first one is 0.4. Right, you can see that the first one is not really smooth. Right, we want something nice and smooth. Of course, the lower you set this value, the more time it will need to calculate the render. All right, so let's set that resolution that we got by doing it by hand, just copying it from the info panel down below. All right, I'm going to go back to our centerpiece code. Just going to set that resolution right away. I'm going to create a new variable called ball and create and get the currently active object. So this active object function is one of the helper functions up above. I recommend you check it out for yourself. Just search for that above the helper functions right here. We will use this ball variable right here. And instead of the currently active object, I'll just use this variable right here. So let's run the script. And you can see that we're still able to run our script. So this function exists, right? You can just search it if you want. And now I also want to set the scale of our metaball to a random value. So I'm going to multiply this scale of the ball by a random value that we're going to generate. So I'm going to go from 0.05 to 0.5. Oops. And let's run our script a couple of times to see how the scale of the metaball changes. And you can see each time we run our script, there's a different scale of our metaball. Okay, now let's work on the path that the metaball is going to be following. And we're going to be using a simple circle curve. Let's do this by hand by hovering over the 3D viewport, hitting Shift A, and then selecting curve and then circle. And this is going to be the base of our path. Let's use the info panel down below to copy the code that generates our path. And I'm going to just remove all the parameters. I'm going to create a new variable called path. And let's just run our script. Of course, let's go into the solid mode. So I'm going to hit Z and then set solid so we can see our curve right here. And now let's use one of our helper functions to animate the 360 rotation. And let's actually find this code above. It's called animate 360 rotation, and it's somewhere here. All right, here it is. And let's just copy all the parameters. And I'm going to scroll back. All right, so we're right here. I'll paste that in. So the axis is going to be 0 for X, 1 for Y, or 2 for Z. Basically, all the coordinates are something like a list, right? And to reference a particular coordinate, like a particular axis, we need to use this notation. So you can use 0 for X, and that's what I want to use. But I have a special helper class that allows us to, instead of using a 0, I'm going to use something more readable. And this is exactly what I'll do. And let me show you what I mean. So here's the axis class right here. I'm going to go into the info panel and paste that in. So now instead of writing 0, I can just do this and it will return 0 for me and make it the code a lot more readable. So let's do that right now. So we're here. All right, instead of 0, I want this to be more readable like so. The last frame is going to be the frame that is going to be the frame count for this animation. And in our context, we have a frame count. This frame count is passed into the centerpiece function through the context, and the context is created in the scene setup. And let's take a look. So this is the scene setup. We're doing some scene setup here and setting what format the render is going to be outputting, and cleaning the scene and doing some other camera setup. And at the very end, we're creating the context dictionary with the frame count, right? So we're using the FPS that we want and the seconds that we want the animation to go, right? And just calculating the frame count and then using that right here. This is going to be what we will use right here. The next thing that we want to set is the object that we're going to be rotating, doing the 360-degree rotation animation. I'm going to use the path. For the clockwise rotation, I'm just going to use a random int, so 0 or 1. I'm going to remove the final parameters because I like their default values. And let's see how that looks. Let's run the script. And I'm going to press space. Actually, let me add the timeline as well, since we're doing some animations. So I'm going to do that. And you can see that we already have some keyframes added for our path. Okay, let's add one more thing to our animation, our path, and that's a random rotation. So we have another helper function that will set the random rotation for our path, and it's called apply random rotation. And let's see how that looks. So notice how the path is going to be slightly tilted in whatever direction that it's going to be generated. So it's using a random rotation. All right, we'll take a look at this helper function at the very end of our video. So we can actually start playing. I'm going to hit space to start playing the animation, just start running our script, and you can see that there's different rotations each time. All right. Now let's make our metaball follow this path. So if we select our metaball and go into the constraints, we're going to add a new constraint, and we're going to add the follow path. So right here, this one right here, and we're going to set the target to our curve, right? And you can see that the metaball popped onto our path right away. So if we press space, you can see how it's moving already, right? We should also make sure that we're animating the path. And that's about it. Let's copy this code. And also we need to set, so that sets the target. Move this a bit, just running out of space here. Oh, actually, this needs to go. This is not for the path, this is for the metaball, right? It should be down here. So instead of this objects right here, Bezier curve circle, we're going to use the variable for our path, right? So we're going to just select that and paste the path. And let's see how that looks. Just run it. And you can see that our metaball is following this path right away. This is good. But you'll see a slight issue right at the end. See that jump, right? When we get to the last frame, it jumps. So the problem here is we select the path and then go into the path animation right here. Then we can see that the duration, the path length in frames is set to 100. So this is not good because our animation is longer than 100 frames, and we need to fix that. So we need to set this to 360. So that's the current number of frames in our current animation. And I'll watch this again. And it seamlessly continues to go into the next iteration of the animation. So let's update this path duration, and this needs to be set for our path. So up here, we're going to use our path variable. So bpy context object is the same thing as the path at this point. And let's try that again. So let's make sure everything works by running our script. Just generating it again. I'm going to press space. Let's do another animation. Here we go. I'm going to skip to the end, and you can see that it's a seamless animation right here. And we can check out the animation path property, and it's set to 360 as we want it to. All right, now let's start organizing our code. And the very first thing that we can do is we can create a function that creates our metaball. So let's just do that. I'm going to just paste in that code. And the thing that we need to pass in into this function is the path, right? So we create this path in another place in our code. Let's spell create correctly and paste that right here. So we're calling our function here. Let's run our script. And you can see that we still are able to generate this animation with the updated code, the refactored code. Okay, now let's create a similar function for creating the path. I'm just gonna create a new function right here. It's gonna be create metaball path. We are going to take this code right here and paste it right here. The thing that we need to pass into this function is the context, right? So we need to pass the context in to get the frame count for our animation. And also we need to return, so we create the path here, and we need to return that path. So in the call site, we're gonna assign whatever is returned from this into a new variable called path, right? These don't have to match, but just for the sake of time, I'm just gonna name them the same. And let's try to run our script again. Okay, we're still able to generate our animation. That is great. Let's add one more touch to our metaball path. And we're gonna use the scaling. So remember how we were scaling the metaball itself? And I would like to scale the path on X and Y randomly. So you'll see in just a second. So I'm gonna use an if. So I'm gonna use if random int right here. So either we're gonna scale the path on X or on Y. And let's see how that looks. Oops. And of course I need to update the variable that's used here. Let's do that again. And you can see that the path itself, it's not really a circle anymore, right? It's like this oval shape. So each time we generate, it's a bit maybe hard to see since like there's no real kind of reference, but you can see that the circle. Actually, you know what? Let me not apply this random rotation to get a better view. And you can see that the path is now these different shapes. I would recommend you play around with the scale, maybe even remove it if you don't like it, right? So you can see how the path is changed. So let's uncomment that. And you can see how the trajectory of our metaball is changing randomly each time we generate our scene. I hope you're enjoying this tutorial and learning something new. Make sure to hit the like button. I'll greatly appreciate it. Okay, now we have something going with our metaball and our path. Let's use a for loop to create a number of these metaballs and path combinations. So let's go into our centerpiece and create a new variable for the number of paths and metaballs that we want to have in our scene. I'm going to set mine to 10. I'm going to indent this by selecting and hitting tab. I'm using this underscore here to communicate that I don't really care about the values that are returning by the range. Just I want to repeat this particular code over and over again, like 10 times. Now let's run our code. And you can see here, I'm going to press Control Space to get a better look. And actually, let's go into rendered. And you can see that we have this right here. It's already something happening. Interesting. All right, let's actually go into solid. Maybe it's a better view. You can see how our metaballs are interacting with each other. This is great. We can generate our scene one more time. You can see that's each time we have different animations, since we're using a lot of random here. All right. So now let's add some color into our scene. If I hover over the 3D viewport, hit Z and rendered, we have our light that's giving us this color right now, but I really want to add a material. So let's do just that and create a new function. I'm going to get a random color using one of our helper functions that returns a random color. Now let's go find our material generation. So I want a reflective material. I'm going to scroll up and find this right here. As you can see, we're just using the regular principled BSDF shader, setting the base color, roughness, and specular, and that's kind of the main shader we're going to be using today. All right, let's scroll back and just paste that in. I'm going to remove this. I'm going to set the name to Metaball. And I'm going to leave the roughness and the specular as it is right here. So maybe we can tweak it later if we wanted to. And one of the properties of the metaball, or just the metaball group, is you don't really need to assign material to all of the metaballs. You just need to assign the material to the very first metaball. And to get that, let's create a new variable. So I'm going to just call it primary metaball. If you have a better name, I'm open for any suggestions. And we can actually see the metaball data if we go into the interactive Python console and then enter bpy data and then metaballs, right? And we need the very first metaball, so that is the metaball that we want. So I'm just going to use that right here. And then I'm going to assign the material that we generated a couple lines before. Actually, we're generating it, right? But we're not even assigning it. So we need a variable right here to get the material, get the reference to the material we generated right there. So I'm going to use append to append the material. So this is a list, right? Each object has a list of materials you can have assigned to it, and that's what I'm doing right here. And now let's copy this and set it right here. And let's run our code. Okay, now you can start seeing that there is some reflections going on here. So maybe it's better. Here we go. I'm gonna press Control Space to get a better view. Press 0 on the numpad to get a view from our camera. And you can see that I'm gonna play our animation by hitting space, and you can see our animation is already coming together. All right. Okay, now that's done, let's create our emissive ring. So in the beginning of the video, you saw that the animation had this nice emissive ring around the metaballs. And we're gonna create that right here in the background function. So I'm gonna be using the curve right here, the curve function. So we want to add that, and I also want to set the radius to be 1.5. And now we need to set the resolution and the bevel. Let's run our script. Let's go into solid. I think that is our curve that we want to work with, and let's go into the curve properties. So geometry, let's set the bevel depth, and let's set the resolution, and just copy these commands from the info panel, just paste them right here. It doesn't really matter the order, but I'm just going to order them this way. Next, we will get our random color, and we will use a special helper function that generates the emissive shader. So it's scrolling all the way up, and then we have the create emissive material, and then apply the emission material right here. I'm going to select this, so this calls the create the emission material, and it's deleting the principal BSDF node and creating an emissive node. Let's scroll all the way back. Let's paste that right here. I'm going to give it a name. You can. I'm going to set the energy to 30. And let's rerun our script. So actually, let's hit C, rendered. Right now, there is no material signed. Let's run this. And now you can see there is an emissive material right here. Okay, now that we have this done, let's render it out. I'm gonna set the samples to 100. You don't have to do this. I'm just doing it for the sake of time. Let's render this image. All right, the render is done. And you probably noticed that something is missing, and that is the glare. So I'm going to put this into slot 1, and then I'm going to create a new slot so we can compare. And by the way, before I forget, because each time we're generating a random scene, but there's a way to pin the scene. So I'm going to paste in the seed. So each time we actually generate the scene, the current seed that we're using is added to the clipboard. So you can paste it in the scene setup function and just pin that particular color combination that you like. So that is pinned, and now we want to add the glare composite nodes. So actually we are generating it again with some helper code right here. I'm just going to copy this. Make sure to take a look on your own what we're doing here, and let's paste this right in the main right here. You can actually go into the compositing tab and see that there is nothing here. And after running this script, I'm gonna run it. Again, see the same scene got generated after running. That's because we pinned that seed. And let's go into the composite tab, and we have some we have a glare node right here that's taking whatever the render layer, whatever the rendered image is. Let's reduce the max samples to 100 for time, and let's render our scene. And unfortunately, I didn't notice that it was using the wrong slot, so it's using slot 1. So, but you can still see, you can try this on your own when you're running the script. You can see that the glare is getting applied as we want it to. Also notice that the nodes are kind of not well organized here. It's kind of maybe confusing. You can actually control the X and Y coordinates of each node, and there's also ways for you to nicely align, to kind of magically align all this through Python. Probably a topic for another video. All right, at this point you're all set to start rendering the full animation. You can go into the render and then render animation and start the animation process. Make sure also to check where the output is going to be going to. So it's in the output settings, and right here is that output file. Note that this might take up some time since we're using cycles, and it really depends on your hardware. Okay, I hope you found that interesting and you learned something. And now, as promised, let's go over some of the helper functions that we're using in this tutorial. And after that, I'll show you how you can get this helper code without having to copy around code. See here, the very first thing that we want to check out is the apply glare composite effect. And it's pretty straightforward. We're just getting the render layers, right? And we're getting the composite node. We're removing right here the glare node. So if there is a glare node in the current compositing node network, we're going to remove it from the scene, from the node network, and then we're just going to add a new one and set whatever properties we want, right? And create the links between the glare node and the render layers and the composite node. So it's pretty straightforward. You can check out how this is done. You can of course work with other compositing nodes as well, so you can like generate them by yourself. So check that out. The lights, we kind of went over this, pretty straightforward, nothing really special. We've already covered the setup scene just in the middle of the video. The main thing I just want to remind you is to check out the time seed helper function. It generates a seed from the current time that you're running the script and adds that to the clipboard so you can pin your scene. So if you really like the color combination or the animation, you can make sure that you won't lose it. Next, let's check out the scene props. The scene props pretty straightforward. Calculating the frame count right here, setting the background to black, setting the FPS, the render FPS, selecting cycles, using the GPU as our main device. So you can use a CPU if you don't have a GPU, and then setting the resolution to a square. So we'll take a look at that in just a minute. Here we're just setting up our camera, so adding the camera at a particular location and rotation. We're setting the focal length and doing the passepartout alpha, right? So it's the border if you look into the camera, into the scene. So right here, you can, probably not the best way to see it. So this right here is what we're setting here with the passepartout, right? This it's slightly transparent, so we can kind of focus in on what exactly is getting into the camera. Then we're adding the empty, and we're making sure to track the empty by passing in the camera. We'll take a look at this in a second as well. Here we have just a palette of colors. You can create your own. And actually, I really advise you, if you do one thing with this script on your own, is just select a new palette of colors, just copy them from your favorite website that has hex color codes, right? Just replace these with a palette that you like and experiment with that. Here we have a special function that transforms this hex code into something that Blender understands. I made a whole video explaining how this actually works, so if you're interested, check that out. I didn't really use this helper function, but I wanted you to see that you can also hit the render animation button right here. This is exactly the call that will start rendering the full animation. Next, we have our material generation code, where we're just generating and applying the material that we created right into our currently active object. So right here is our reflective material, right? So if we go into, so we select our main metaball, then we go into shading, and you can see that this is exactly what we create with that code. And it's just material creation, and we update the base color, specular, and the roughness. So that is what this code right here is doing, right? So we're updating the base, the roughness, and the specular. Something to watch out for is, like, if you want to update other parts of this shader, so when you update it, right, like so, you can actually go into the info panel right here, and this will actually be the command that you just did by hand by modifying the shader. But notice that the inputs, it's using number, right? Not super readable. You can actually replace the number with text, so with a string. So make sure to, that was, I think, metallic. So make sure if you're doing that, just add metallic into that string. So like so. Next we have our emission. Similar idea, only we're removing the principal BSDF. So after, by default, we have a principal BSDF node in our shader. We're gonna get that node, and then we're gonna remove it, and we're gonna add a emission. So let's actually select our circle and go into shading, and you can see that we added single emission. There is no principal BSDF node. So this is exactly what this code here does, and we're doing we're linking the emission with the output node that actually allows Blender to use the shader during the render. Next, a helper function that uses this particular function, creates a material, assigns it to the currently active material, right? At the very beginning of the tutorial, I referenced the apply random rotation. So we're literally getting the active object and using the Euler X, Y, and Z rotation axis, and just creating a random rotation, getting a number from 0 to 360, and then converting the degrees. So this is in degrees, right? But Blender needs everything in radians, and that's what we're doing with this math right here, a math function call. And then we have the apply rotation, and probably one of the final things I wanted to share with you today is this animation rotation. So we're just selecting our active object. We're keyframing the Euler rotation with a particular axis. Remember, we're using this class right here, right? We can pass in that right here, setting the frame, then deciding which way we want to turn, clockwise or counterclockwise, setting the last frame, right? Doing the rotation, so setting the rotation at the final keyframe, and then inserting that particular keyframe. And if we want to make sure that the rotation is linear, then we call this set f curve extrapolation to linear. Let's take a look at that. Let's see here, it's right here. So we're just looping over all the actions and looping over all the f curves, and then just setting the extrapolation to linear. By the way, here's setting the scene resolution of the renderer, right? So this is the 1080p by 1080p here, and yeah, I think that's it. And yeah, this is the conversion code of the hex color code to a RGB value that Blender understands. You can check out this tutorial right here. And that's probably the main thing. Most of these I've already covered in my other tutorials. Make sure to check those out. And for the final thing in this video, I wanted to show you how you can get the same scene generation without having a lot of this helper code. Okay, now let me tell you how you can get all these helper functions for yourself without having to copy around into every single script that you work on. I have a special Blender Python package that's called bpybb, so bpy building blocks, and that package contains a number of modules that contain these helper functions. And to get them, you can download a special add-on that adds these modules to Blender Python. To get this add-on, you should go to cgpython.com/bpybb. This will redirect you to a GitHub page with the latest release of this add-on. And then you should just select the assets, download the current zip of the add-on. Okay, as soon as that's downloaded, let's install that add-on, go into Preferences and Install, then go into the downloads wherever you downloaded that zip file. Now let's install that add-on. Let's enable it. Also, if you've been following my other videos, you might have installed older versions of this add-on, so make sure to disable that, right? So if you have older ones installed, make sure to disable that, and maybe you would want to restart Blender just in case so the paths are correctly updated, right? So this add-on, the basic idea is it contains this Python package, and it updates the Python paths for Blender's Python and allows it to gain access to all this functionality. So now that's enabled. Let's remove all the code that we don't need. So I think if we delete everything from going from here, so I'm going to just remove all this code, scroll all the way up and remove that, and then paste in the imports for all these helper functions. Just going to paste them right here. So these are all those helper functions that you just saw and that are used in our script. So like without this, right, I'm going to comment this. This is not going to work, right? We get an error, so we can't clear in the scene, right? That's because the function is gone, but we can import that functionality by using the bpybb Python package, which contains these modules right here, right? We actually don't need, I think, time and math as well. So now let's run our script. And as you can see that we're still able to generate our scene just using these exact helper functions that are hidden away under these import statements right here. So see, now we have a lot less code to think about and worry about, right? We only have the glare composite, the add lights, the scene setup, the scene props, setup camera, and the get random colors, right? So now this code is really compact, and you can see how you can use this in your own projects and scripts. I have another video about this Python package of how you can install it through pip. If you know what that is, you can check that out. But this is everything that I wanted to share with you today. I hope you enjoyed it, and thank you so much for watching.